Okay, so problem 4 is where we have the spider hanging from a thread, and there's a fly that hits the thread. The thread is light and frictionless. And actually, I think it was Andrew Martin in my second period who pointed out today that if the thread is frictionless, how does the fly get stuck in it? And my only answer to that is touche, Andrew. Yes, you've found out why the problem is completely illogical, but I'm going to solve it anyway. So it's a frictionless thread draped over this like tree branch or something. So, which I mean, the point is this acts like a pulley, right? So the spider's hanging on the end. The fly gets caught here. We know the fly weighs less than the spider, or has less mass than the spider, and so we want to find the tension in the strings here. This is, of course, fixed to the ground at this point P. For some reason, the letter P has not shown up here. But, trust me, there should be a letter P there. Trust me, because I wrote this. Okay, so this is actually a fairly easy problem. So nobody's moving, right? These guys are just hanging here. The fly is stuck. The spider is maybe still asleep or something. I don't know. So let's do a free body diagram for the spider. And let's get problem 3 out of the way. Okay, so here is problem 4, and the spider is. So let's just launch straight into a free body diagram for the spider. Spider. Okay, and the spider. I'm just going to take the standard XY coordinate system. Spider has this string above it. The tension on this string. Well, remember, when a string goes around a pulley, tension doesn't change. Tension is still the same. So the tension of the string here is also T1. So the spider is going to have a tension T1 pulling up on it. And hi, that's my fiance getting home. And there's the spider's mass pulling downward. So this is pretty easy. Sum of forces in the y direction. The spider isn't moving, so the sum of forces is going to be 0. You got T1 going up. You got minus ms times g going down. That equals 0, which means the tension in string 1 is just the mass of the spider times g. Okay, so let's look at the fly again. So we know the tension here, which means we know the tension up here. So we've already found T1 actually. Now for T2, let's just do a diagram for the fly, and let's see. So let's just free body diagram for the fly, and let's see. So there's our fly. There's the mass of the fly times g. There is the tension in string 2 pulling down on the fly, and the tension in string 1 pulling up. We knew this was MSG, right? So we can just go ahead and say MSG if we want. We do a force balance in y equals 0, and so we have T1 going up, we have T2 going down, and we have the mass of the fly times g going down. That equals 0. So we know that T1 is mass of the spider times g. So MSG minus T2 minus MFG equals, oh, why did I do that? Okay, minus MFG equals 0. So this is MSG minus T2 minus MFG equals 0. Right, so then we can get from there to say that T2 equals G, so we can bring the T2 over to the side, G times mass of the spider minus mass of the fly. And then, guess what? We're done. We got T1 there, and, well, yeah, close enough. So T1 that, yes, that's right. I can solve the problem faster than I can draw boxes around the answers. Jeez. All right, good enough. T1, T2, done. I would solve the bowl problem next, but my fiance got home and I want to spend some time with her. So I'll finish the rest of these in a bit. So talk to you guys soon, I'm sure.